Hello, everyone. So essentially, at the end of the day, I'm here to crush your souls. It's going to be a fairly long talk. There's going to be a lot of technical stuff in it, so you better be prepared for that. The title of the talk is a little bit different from what you saw on the website, but the content is exactly the same, because I want to talk about things you can do with SVG beyond displaying simple images. And you can do those things when you start looking at SVG more as a document format instead of just an image format, just like JPEG or PNG. In fact, did you know that in Doctor Who Season 2, Episode 7, I think SVG was being used to launch missiles? It is that powerful. Now, seriously, though, there is a lot that is possible with SVG that a lot of developers are not taking enough advantage of. I don't know if it's because they don't know enough about it or because of browser support and browser bugs. Support is really excellent for SVG, but when it comes to bugs, you have a lot of those. So in this talk, I want to go over a few separate and different techniques that you can use SVG for in less than, it's not just about displaying images. I'm going to show you some examples. I added a couple of new sections today that hopefully are going to be most interesting for some of you. So if you find some of the first part of the talk not too advanced, you may find something for you in the second half. So I'm going to start with cropping, scaling, and preserving aspect ratio using SVG. Now, when I talk about cropping and scaling and preserving aspect ratio, we're usually talking about two attributes. The SVG view box, which I like to call the SVG superpowers. It's my absolute favorite thing about SVG. And its cousin, the preserve aspect ratio attribute. Together, you can create all kinds of really great effects. If you're a developer who doesn't like to do anything in a graphics editor such as Illustrator and the likes, and you still need to edit something about the SVG, such as when some of the SVG is clipping off and you need to increase the boundaries of the SVG inside so that you don't get that clip off in Firefox, you can do that using the view box without having to jump back into the SVG editor like Illustrator or such, other editors. Okay. You didn't even notice that I was messing it up, but I made you notice it. Okay, so before I jump into that, first I need to make a distinction between the SVG viewport and the SVG view box. The SVG viewport is, so when you're talking about SVG, it gets a little bit confusing if you're just starting out, because there's a view box and there's a viewport, and the way these two are named, the view box versus the viewport, is even more confusing. So the viewport is usually defined by the width and the height of the SVG. The viewport defines how the browser is going to use the SVG, or it defines how the SVG is going to be used by the browser in the context of the page. Just like HTML elements that have width and height attributes that define how they are going to be laid out in a page, it's the same with SVG. So when you set a width and height on an SVG, you're creating a coordinate system, just like with HTML elements, a width and a height, and the browser is using that in the context of a bigger page, wherever you're embedding the SVG. But when it comes to drawing content inside of the SVG, this is not the coordinate system that the browser needs to use. So see, inside of the SVG, the content is drawn on an conceptually infinite canvas. That canvas is the space, I'm just going to read this out loud. The canvas is the space or area where the SVG content is drawn. Conceptually, it's infinite in both dimensions. Now, the SVG can therefore be of any size, but you're only going to be able to see a part of that canvas within that viewport. So it's just like an iframe and Google Maps. So you have an infinite Google map in the background, but you're only seeing a part of that map through that iframe. You can move the map around and see different areas of the map. So when I do think about it, and it might help someone else, I usually think about SVG in two layers. So the first layer is the SVG itself, sort of like a stencil, the paper. And then there is a background layer, which is infinite, and that's where all the drawing takes place. Now, if the browser is not going to use the viewport to do any of the drawing, it's going to need another coordinate system, and that's what the view box is for. So the view box defines the coordinate system that the browser is going to use to draw inside of the SVG. It is, as every other coordinate system, you're going to need an origin for that system, the point that has an x and y, and then that coordinate system also has to be finite, so it has a width and a height. I'm going to do a live demo quickly. Okay. So this is a demo that I created about 4 years ago when I was getting started trying to understand SVG, and I started changing the value of the view box just so I can understand what it does, but the results were always completely unexpected. I had no idea what was happening. So the only way for me to be able to know what's happening was to visualize it. So I created this tool here. The gray, let me just change this a little bit. The gray coordinate system is the viewport, which is the width and the height of the SVG, and the blue is the coordinate system inside of the SVG on the canvas. So initially, when you create an SVG in your graphics editor and then you export that, you're going to notice that the view box has a width and a height that are initially identical to the width and the height of the SVG itself. So this is what it would look like at first. You're not going to see, oh, you did see a cat. I usually don't show any cats in my talks because I'm a bird person. Yeah. So I have a parrot here and it's positioned up there. So it starts getting interesting with SVG when the coordinate system inside of the SVG does not have the same aspect ratio as the viewport. So the view box and viewport don't have the same aspect ratio. I can visualize that by changing the height. So this is what I have right now. So I have content inside of the SVG. This could be anything. It could be an image, for example, a JPEG or a PNG image or whatever you have there, okay? The aspect ratios of the view box is not the same as the viewport. How many of you are familiar? I'm pretty sure that most of you, maybe even all of you, background position and background size in CSS, all of the values and how they work. Okay, view box and preserve aspect ratio do exactly the same thing. So you start with a view box that has a different aspect ratio than the viewport, okay? Is it still on? Oh, yeah, okay. Now, the next thing you want to do, usually when you embed a background image on an element, and the background image has a different aspect ratio than the element itself, you're going to end up with something like this. The browser is going to put that image, it's going to contain that image, which is the background size contain, inside of the element, and you're going to end up with some white space at the top and at the bottom, right? And then you can use background position to position that image. You can either position it at the top left or even at the bottom left, whatever, any way you want. Or you can also choose to scale the image up as much as possible to fill up the entire background area, even if that means clipping off some of that image. With SVG, you can do exactly the same that using the preserve aspect ratio attribute. So we have meet and slice. The preserve aspect ratio attribute is made up of two parts. The first one is the align. I'm going to get to it shortly. And then the second one is a keyword, which is either meet or slice. Meet is exactly the same as contain on background size. It means that the browser is going to scale whatever content you have, but it's going to still be contained inside of the viewport. Nothing's going to get clipped off, which means you're going to end up with some white space. You may want that, depends on what you want to do, or you want to scale it up, just like background size cover, and you can do that by choosing slice. Now, what happened here is the view box was scaled up. As you can see, this is the coordinate system here in blue. And it was initially centered. So if I go back to here, it is a little confusing with this particular illustration because I have a lot of white space here. But what's happening here, it's scaling up, but it's initially centered at the center of the viewport. The center of the view box is positioned at the center of the viewport. And then you can use the alignment attributes, values. For example, xmin, ymin is exactly the same as left 0, top 0. And if I choose that, it's going to position it at the top left. And then if you go back to xmax, ymax, it means x 100%, y 100%. And that x 100%, y 100% is going to be aligned with the x 100%, y 100% of the viewport, which means that for this particular case, you're not going to see anything. You're going to get white space. Let me do that. Yep. So this is the view box, but the bottom right corner of it. You're just not seeing anything because I chose a not so ideal illustration. So this is practically everything that I wanted to show here. The view box can have a different aspect ratio than the viewport, and then using preserve aspect ratio, you can move it around and scale it up and down any way you want. So let me switch back here, and I'm going to need my speaker notes a little bit. Okay, so play that. Okay. So because of our ability to use and manipulate the inner coordinate system and scale it up and down, we can create a lot of different effects. Now, one of the things that we usually need in CSS is the ability to scale and position images and videos. Okay? So in CSS, we have the object fit and the object position properties. Using object fit, the contents of an image or a video can be set to scale up or down, shrink or stretch as necessary to fit into whatever size you have. Suppose you have an avatar image. Usually, most of the times, they are square. Okay, and you have WordPress or whatever you're using, and you're allowing the user to upload any kind of image. That image can be JPEG, PNG, and it can have any aspect ratio. But you want that image to be a square image on the page. The way you want that non-square image to be positioned inside of that square area can be specified using object fit and object position. The values can be any of these. So you have the original image here on top. You can see the mouse, okay. So if you use object fit, fill, the browser is going to scale the whole image inside of the small square, which is the first one here under the original one, without preserving the aspect ratio. You can choose contain, which is similar to background position contain, which means the aspect ratio of the image is going to be preserved, but it's going to be shrunk as much as possible to fit in that square. You can choose cover, which scales it up as much as possible with cutting off a little bit of it. By default, it's going to be centered, and you have all of these values. Using object position, you can change them, which is all good. But browser support for object fit is not really very good. So if you really, really need to do this kind of cropping inside of in your application and you need to support IE or Edge, you're probably better off using something else. Or, well, if you don't really care about IE and you only want to use this as an enhancement in a modern browser, you can use it with the supports rule. So you can check for browser support for object fit, and then you can scale that image in every browser that supports it. But if you need better support, you can use SVG. So you can crop all of your images. Remember how I mentioned earlier that the view box can contain anything? You can even have an image, a JPEG image or a PNG image inside of the SVG. So this is exactly what we can do here. So this snippet here is all you need in order to achieve the exact same scaling capabilities that you get with object position and object fit. So X and Y here are the width and the height of the SVG. And, well, we're talking about squares, so suppose that it's a square here. The image X and image Y inside of the view box are the intrinsic dimensions of the image that the user is going to upload, assuming a user is going to upload one. Align and meet or slice are what will fit and position the image within the SVG. Now, we're using the view box and preserve aspect ratio to crop and position the image, which serves only as, so SVG here it's not really displaying an image. It is used as a container for another image format. And this is exactly what we're doing here. Just like a div, it almost doesn't have any rule, except that it gives you the functionality. That's all. So as an example here, 140 pixels by 140 pixels, image square. The user uploads 800 by 500 pixels. Align and meet or slice, I left them open because that will be up to you. If you want to align them, align to the center, to the top left, change the scaling, it's all up to you. Now, this snippet here is all you need. Instead of using an image tag and using object fit and object position, you can replace that image tag with this. But there are two problems here that I can think of. Can anyone say one of these problems?
File size?
File size? No, you can optimize that. We'll get to that shortly. What?
Cross-origin resource sharing?
No.
Security?
No. No, we already have, you can get those, PHP, whatever. That's not, the problem is with the code here.
Oh.
The width on your image? How's that going to work with the view box?
No, come on, accessibility, hint.
Title?
Exactly. So an image tag has an alt attribute. An alt attribute is necessary for accessibility. You should never, ever omit it. If your image is decorative, you can leave the alt attribute empty, but you should never omit it. Now, we don't have an alt attribute on the image element inside of SVG, but we have something else. You can use the title element. The title element in SVG it has exactly the same functionality as the alt attribute on an image tag. So just like you would provide an alt attribute for your image, you do that with the title element here. I should also have added ARIA labeled by, because some of the screen readers and accessory technologies don't really, it just reinforces the relationship between this title here, and the SVG. Yeah, that's pretty much all you need. And this works across all browsers that support SVG. You get object fit, object position using SVG. But there's another problem here. In one of the previous conferences, someone asked me about this. You can only provide one image What if you want to provide multiple image resolutions? Like if you're using responsive images and you have multiple images using, if you're using just HTML, you could provide a picture and the source set attributes, and you can provide multiple images. Can you do that with SVG? No, because we don't have a source set attribute for the image element. But you can do something else which would sacrifice some of the browser support. Instead of using an image tag, you can use the foreign object. The foreign object essentially is a way to tell the browser that I'm literally putting a foreign object inside of my SVG, which means that the content inside of foreign object is not SVG. That's all. Now, inside of it, then you can use, instead of using an image with just one source, you can use picture, source set, whatever you want, and it should work out of the box. However, you're going to be sacrificing some of the support. So if you use only one image, you're going to get the support in all SVG browsers. But if you use foreign object, you're only going to get Edge and above. So you're going to lose IE completely, because IE does not support foreign object. Optimizing image sizes with SVG masks. This is the shortest section of all, but there's a little bit of talking there. Now, JPEGs have better compression rates than PNGs for photographic data. Okay, wouldn't it be awesome if we could get the compression rate of a JPEG while preserving the transparency of a PNG? Using SVG, you can do that. Again, in this example here, our SVG is going to serve merely as a container for the bitmap image, and then we're going to use an SVG mask applied to that image in order to get the transparency that we want. So we want the file size of a PNG. We want the file size of a JPEG, but we still need the transparency of a PNG image. So the idea behind this technique is to use an SVG mask to clip out the areas of the JPEG that you want to be transparent, and then you serve that JPEG itself. So this is what it would look like. If you have a JPEG image here that is, again, a DOF, and then you create a mask. In this case here, we're using a luminance mask. So everything in black is going to be clipped out, and everything in white is going to be kept. You have a JPEG image. You create your mask in order to clip out the areas that you don't want, and we get the result here on the left. Size of a JPEG, transparency of a PNG. And this is what the code would look like. So the mask is referenced inside of a mask element, which is then wrapped inside of a defs. Defs is used to define anything you want inside of the SVG. Definitions are not going to be rendered on the page. So we have a mask here. It's not rendered on the page. It is only defined so that you can use it somewhere else and apply it to some other element. The SVG, the mask, and the image have the same dimensions, and that is all you need. Of course, since this technique relies on SVG and SVG masks, it's only going to work in browsers that support SVG. If browser does not support this, you're going to have to provide some other kind of fallback. In addition, it is recommended that you inline the SVG to make it work across most browsers, because referencing an external SVG containing images using an image tag can be problematic. I haven't tested in which browser, but I'm guessing it's Firefox, because it's the only one that gives me all of the headaches when it comes to referencing stuff externally. One last thing before I get to the real meat. Optimizing SVG delivery with SVG. So I love using SVG to solve problems, real-world problems. The new Smashing Magazine design that you can find now on smashingmagazine.com, I built the front-end foundation for that. In case you didn't know, I'm a freelancer. I write so much and speak so much that people don't know that I actually do this for a living. I code for a living. So I built the front-end foundation for the new Smashing Magazine. It has changed a lot since then. That's just a heads up. But I built the initial foundation. And one of the challenges that I had is we had these illustrations that have also changed, but the complexity of the illustrations is still the same. And the technique used to embed them is also still the same. So we had these small Vitaly illustrations. Each one of these illustrations is used, they have this new Smashing membership. They have 3 different types of memberships, and each type has a name. You have supporter, you have member, and you have I Feel Smashing. Now, for each one, imagine a pricing table. You have 3 different columns. Each one should have a title, the title of that membership. Now, instead of using an actual HTML heading, we're using an image to display that heading. So these images are the actual headings. So there are a few requirements there. The text inside of these images needed to be searchable, selectable, and accessible. Okay? Which means that using JPEG or PNG was not an option. Now, the first thing that I usually do when I want to embed an illustration, you don't always You shouldn't always use SVG, even if SVG is or seems to be the best option. Sometimes if the SVG contains a lot of effects, a lot of small details, a lot of complexity, the file size of the SVG gets so big that it's totally not worth it. It's usually better to use a PNG version instead. Now, in this case, I tested it. The size of the PNG versus the size of the SVG was pretty much the same, so using SVG was fine. I wanted the text to be searchable, selectable, and accessible. The best way to do that is to embed the SVG inline. By the way, if you want me to go slower, someone just tell me to slow down. Oh, okay, okay. I'll just have some water then. Okay, 3 SVGs. The text inside of these SVGs is real text, so it has to be searchable, selectable, accessible, also good for SEO. No JPEG, that has been established. SVG, you can embed it inline or you can embed it externally using an image tag or using object or using one of the 7 different ways to embed SVG. Now, ideally, the best way or the most ideal way to embed SVG is to use it inline. However, one of the reasons that I wanted to do it inline is because I was also, these titles, since they're actual text, I was using a font face from the main style sheet. So I was applying the Miha font face to that text, and I wanted to be able to do it. So if I embed the SVG inline, I can style all the content inside of that SVG from the main style sheet, no problem. But if I embed the SVG using an image tag, so we're referencing an external SVG inside of the page, and you want to style the text inside of that page, you would have to either define the font face inside of the SVG file itself, or reference a style sheet from within the SVG. So that would be 2 places, defining the styles in 2 places. I didn't want that. I try to search for the shortcut all the time. So I was like, inline, perfect. But it's actually impossible to inline. Each one of these images look like this. It's not finished yet. Now it is. No, now it is. Inlining these was impossible, but I still didn't want to have to define the font face inside of the SVG. I'm just stubborn like that. So I said, I want the text to be in line, but I don't want this to be in line. So I was in an airplane on my way to, I think, to Smashing Conf, and I was sitting there, and I was thinking, well, I want to get both. I want to do both, right? So what if I separate the text from the image? Because SVG is a document. It's not like a JPEG. Like, it's not fixed. You can do whatever you want with it. So if I remove the text from within the illustration, and I embed the text inline, in an inline SVG, and then I reference the SVG illustration, the rest of it, inside of that inline SVG, so I have an image and I have text, and all I have to do next is to just position the text on top of that illustration to match the original design. Would that work? I tried it, and I was sitting, and there were a couple of men sitting next to me, and when it worked, I was like, yes. I got the weirdest looks in the world back then, but I didn't care, because it was really awesome. So this is the solution here. SVG, title, accessibility, supporter plan, reference that illustration without the text using an image tag, so it doesn't get any more meta than this. So you're referencing an SVG inside of another SVG. And then you add the text inline. I've kept this intentionally, it's not a mistake. Do not ever write words like this in all capital, because screen readers are going to read this out loud as SUPPORTER. So don't capitalize in your HTML, capitalize in CSS only. And this is all you need, and then you just style the text from the main style sheet, apply a font face, apply fill color, font weight, whatever you want, and it works. Now the takeaway from this section is that you don't need to choose just one SVG embedding technique. Because the SVG is a document, you can split it up. You can choose more than one embedding technique. Now, SVG can do filters, and I'm pretty sure that most of you already know this, but I want to go over 2 specific use cases or examples of things you can do with SVG filters. The first one is applying texture. More specifically, how you can use an image of a texture, in this case I'm going to be using fabric, and use it to change the shape and texture of elements, specifically text. Again, in this case, SVG is going to be just a container with some magical filter functionality in order to display actual real text. In particular, I'm going to be creating this effect here. I borrowed this from a Photoshop tutorial that I found on YouTube because I'm not a designer. I don't even know how to create this effect in Photoshop. Now, in the video, the designer created this effect by using what is known as a displacement map. A displacement map is an image whose color information is used to distort the content of another element. In SVG filters, we have an element called FE. FE is short for filter effect, displacement map, primitive that uses the pixels from an image to distort the content of whatever it is applied to. Now, in order to create that effect, this one here in Photoshop, the designer did first started with desaturate the image so that it's black and white, reduce the amount of details in it by blurring it by 1 pixel. If the image has a lot of detail, too much detail, the effect is not going to be realistic. If it has too little detail, it's not going to be realistic either. So it has to be somewhere in between, and 1 pixel blur is usually the most ideal amount of detailing. It's not even a word. Save that as a displacement map. So desaturate image, blur it by 1 pixel, save it as a displacement map, and then create some text, apply a distortion filter using the image as a displacement map. This is all Photoshop. So you apply effect, distortion, and then you use that image as a displacement map. And then, so you have now distorted text. You're going to see it in SVG shortly. You have distorted text without a background. So you just include that original image as a background behind the text again. It already looks almost very, very realistic. And then refine the effect more a little bit by adding a little bit of transparency to the text, maybe a little bit of blending modes, and you get the result that you want. Now, in terms of SVG, it looks almost exactly the same. So fill the filter region area. Every filter is applied to a filter region. In this case, if we don't have anything else in the SVG, the entire SVG is going to be the filter region. So you fill it with the image that will be used as a texture using the image filter primitive. You're going to need to go deeper into each one of these primitives later. I would give an entire talk on SVG filters if I could, but it's not for today. Desaturate the image using the color matrix attribute, using the color matrix element with the type value saturate, which is a shortcut. You're going to see it in code shortly. Apply a 1 pixel Gaussian blur to the image using FE Gaussian blur. You have a filter primitive for almost everything, and we even have a filter primitive convolve matrix. That is the most complex of all. I haven't understood it yet. Which allows you to create your own custom primitives. Use the image to distort the text, so you have the image blurred, desaturated, and then apply it as a displacement map to the text. Blend the text into the image using FE blend and apply a translucent effect to it, decreasing the opacity using component transfer to make the effect look more realistic, and display the image and the text on top of each other using merge. We're going to start it step by step. So we have an image here. FE image references our image that's going to be used as a displacement map. Desaturate the image using color matrix type saturate, value 0, so it's going to be completely saturated. And filters in SVG are it's sort of like a pipeline. So the result of one filter will be used or can be used as an input to another filter. So in this case here, I have an image that I'm using for, so when I'm applying color matrix here directly after image, it is automatically applied to that image. The result of the color matrix desaturation is called image. And then apply a Gaussian blur. So this filter takes in the image result, applies a standard deviation of 0.5. Actually, this should be 1, not 0.5. And then I'm giving that a name, map. This is my displacement map. Okay? This is the result here. And then you use the displacement map function. So it takes in the source graphic, which will be our text. You're going to see it shortly. The second input is the map. So I have the text, and then I have the map. I have the map applied to the text. X channel selector, Y channel selector, these are all details. Essentially, you're using the RGB channels too. Remember when I said the browser uses the color information of the image to distort the text? This is it. And we're getting a result called texture text. And then this is not really necessary. What I'm doing here is the FE color matrix. Again, this could be an entire talk on its own, but essentially this 0.9 here, this is the alpha channel. It's by default, it's 1. When I'm setting it to 0.9, I'm setting the opacity to 0.9. And this is the result that I've had so far. So I had that texture. I've applied it to the text. This is what I have here. And then and notice here how the displacement map is not visible anymore. Because so first we had it desaturated and all, but as soon as you apply it to some element, it's gone. It's just something that you're using. It's not something you're displaying anymore. So we're going to have to add that shortly. This is a little bit of refining. I'm changing the contrast on the image using component transfer. Again, too much for another talk. So the image has a little bit more contrast. And then I'm blending the text with the background image using blend modes in SVG. In this case, I'm using the multiply mode. And then I'm merging them. So FE merge is essentially literally just merging. So if you have multiple elements that you want to show at the same time, you put them inside of a merge. I have here the background that I want to blend with the result of the blended text. And this is the result here. And this is the Photoshop tutorial that I stole this effect from. Now, this is all cool, but SVG can even do a lot more complex stuff, like create texture. And then you can use that texture to do exactly the same thing or much different stuff. So SVG can create rich textures using what is called as the turbulence filter effect. The turbulence primitive generates and renders Perlin noise, random noise. This kind of noise is useful for simulating several natural phenomena like clouds. You can do that in SVG. You can create clouds in SVG. Fire, smoke, complex textures such as marble, granite, stone. It can all be done. Just a little bit of tweaking. You know, just is a really bad word because it's not that simple. A lot of tweaking in SVG filters, and you can get all of these results. So turbulence fills a rectangle with new content. Okay, so in our case, our rectangle is going to be the entire SVG again. So first things first, a little bit about FE turbulence, because the attributes on this primitive are everything. They're going to define the texture, the complexity of that texture, the details and stuff like that. You have base frequency type, num octaves, seeds, stitch tiles. The only 3 attributes that you will want to worry about most of the times are the type, base frequency, and number of octaves. The base frequency specifies the grain of the noise. Very low values, such as 0.001, will produce large patterns. You're going to see an example shortly. Very high values, very high, such as 0.5, are going to produce tiny patterns. Values in the range 0.02 and 0.2 are useful for starting points for most textures. I'm going to share a link to these slides with all of the speaker notes, so essentially everything I'm saying after the talk. Okay. There are 2 types of noise as well, which you define in the type. You have fractal noise and turbulence. Turbulence is more noisy, and fractal noise has a more smooth, more like a cloudy effect. Num octaves, which is the 3rd attribute you need to worry about, and keep this in your mind, it is used to define the number of details. It is just like number of octaves in music, so the higher the number of octaves, the more details you have. Usually a number of octaves up to 5 is almost the highest you will ever need, because as soon as you start getting to 6 and higher, the effect is not as visible anymore. So these are some of the different effects that you can create using turbulence. These 12 images represent 12 results of noise created with turbulence with different types, base frequency, and num octave values. The link at the bottom here, if you go to it, you're going to see the values for each one of these rectangles. But just a quick recap or quick overview. In A, the base frequency is set to 0.04. B is exactly the same as A, but we're increasing the number of octaves to 2. So B is A, but with more details. D is C, but with more details. There's a seed. I'm not going to go into that now. So F, remember how I said that the noise, you can create larger patterns or smaller patterns depending on the number of the base frequency. So F is an example of larger patterns. I and J are examples of fractal noise, so it looks more cloudy than all of the other noise. And you can also specify if you want the noise to be one directional only. So it's either horizontal like in K or just vertical like in L, which can be used to create some really great effects. Now, this live demo here is an app online that can also play with. I'm applying a turbulence here to an image. This is the turbulence created, and you're using that turbulence as a displacement map applied to that image. So it's distorting it completely. And then you can also add some text and apply that turbulence to text to also get different effects. Some demos have been created online using these techniques. So you have this water splash effect in one of the Smashing Magazine articles by Dirk Weber. He has created a lot of really amazing techniques if you want to look at them. So we have an FE turbulence here, and then it's going to be used as a displacement map. Codrops has also created some really neat effects. These jiggly effects, these ripple effects, this is noise. Because the values, all of the values of base frequency and num octaves, these are numbers, and numbers can be animated. So the last one, did it play already? The one with the music, this is horizontal turbulence, and it's being animated. Simple as that. So what I want to focus on now is how you can use this noise and turbulence with lighting effects, because you have lighting effects in SVG, in order to create texture. In a second. Do I have enough time? Okay. So one fairly simple texture that can be created and that most people use most of the times is the texture of rough paper. This rough paper can be created using SVG only, no images at all, using 2 steps, just 2 filter primitives. But of course, before you write those filter primitives, you're going to have to experiment a little bit. So we're going to start by creating the base for this whole effect using the turbulence primitive. I'm not specifying the type, so by default it's going to be turbulence, not the cloudy one, the other one. The base frequency is 0.04, just some place to start with, and the result is a noise. It's going to fill or be applied to a rectangle, which is the size of the SVG itself. So we're filling the SVG with this. This is the noise generated with the primitive that I just showed you. Next, before we start fiddling with the values of this, we need to shine a light on that surface. Now, shining a light on a graphic provides additional depth and texture. To create a lighting effect in SVG, you're tired, aren't you? To create a lighting effect, you need to specify three things: the light color, the light type, and the light source. Types of light in SVG can be diffuse lighting or specular lighting. In other words, it can be some lighting just like the sun, a very far light, or a light just like the lamps here. It's closer and more specified, more limited, sort of. Both primitives shine light on an object by using the alpha channel of that image as a bump map. This is the key thing here. So if an image has an alpha channel, the browser is going to take that alpha channel and create a bump map out of it. So if you have the alpha between 0 and 1, imagine it's going to create a map that is all made up of hills. The lower the opacity, you'll be at the bottom of the hill, and the higher you'll be at the top of the hill. So you have this bump map created from opacity. Now, because the filtered primitive turbulence generates an alpha channel full of noisy values, this noise has also an alpha channel, which also varies from 0 to 1. It produces a nice variable Z terrain that creates highlights when we shine our light on it. Sources of light can be distant or can be FE point. No need to get into the details of these. So I have a turbulence, and I'm applying some light to it. These attributes, again, you can look into them a little bit later, and this is the result that I get. There's too much sharp edges there. I want something smoother. So if I want to get a more smooth noise, what do I use? Blur? Not blur, no. Fractal. So you have 2 different types of noise. The first, the turbulence, which is sharp, and the second one is the fractal. So if I switch to fractal, it gets better. But when we're talking about rough paper, it's called rough for a reason. You have more detail. How do I increase the number of, how do I increase the amount of details? Num octaves. Increase the num octaves, and this is what you get. It's much better. You can change the effect a little bit more and tweak it by playing with the source and distant light. So for example, decreasing the elevation of the light, making it closer to the texture, will increase the contrast between these small hilly areas, and the image would look a little bit more like this. This is closer to sandpaper than it is rough paper, so our previous result is what we were after. Create noise, apply light, you got texture. You can create much, much more, a myriad of different effects just by changing the noise, texture, and lighting. You can also add, you have noise, you have parallel noise, completely random. You can use matrix, FE component transfer, other primitive in order to change, remove some colors like red and keep others. You're going to end up with some blotchy effect, blotchy noise, which you can then change to something else. And if you make it cloudy, you're going to have blotches of cloud, getting you closer to cloud and then to fire. The sky is the limit. So these are some examples, just applying a little bit of blur, applying sharpness, increasing the sharpness of that parallel noise, removing some color channels and keeping others. I can see some bokeh effects starting somewhere, a little bit of fireworks maybe. The sky's the limit. The last one. So conditional processing inside of SVG, providing fallbacks natively. So you may or may not know that the SVG document structure specification, the SVG spec, defines elements and attributes that give us the ability to specify alternate viewing. This is just blah, blah, blah for saying you can provide a fallback for your SVG content using nothing but SVG itself. And it looks something like this. So the switch element renders the first of its children, which in our case is the use element. If the switch element has a few attributes, you don't have to change those. By default, the default values for these attributes are going to be either true or false. If they are true, the browser is going to render the use element, if a browser does support SVG. If it doesn't, it's going to jump completely all the way back to the content of the foreign object. So what's happening here? If a browser supports SVG, it can understand the SVG tag, it can understand the switch tag, so it will render the use and ignore everything below it. All good. If a browser does not support SVG, it doesn't understand, it's going to skip over the SVG tag, skip over the switch tag, skip over the use tag, skip over the foreign object, and render the first HTML it finds, which is our fallback image. So if you're using an inline icon, an inline illustration, whatever, you can reference it using use and provide a fallback here. Now, the fallback is going to be a background image applied to that empty div. But there's a gotcha with this here. If you have this code here, if a browser does support SVG, it's going to request the fallback image anyway, even if it's not going to use it. So I'm almost done. So there's a way to avoid that by introducing another inline SVG onto the page and then getting rid of that fallback image by setting the display to none. So a couple of things to note here. If a browser supports SVG, it's going to find the second SVG and apply the fallback style to that fallback div. Display none. If you set display none, the image is not going to be downloaded anymore. We solved that problem. And why does this work? Because if you have two inline SVGs on the same page, any styles that you define in one of them will affect elements in the second one. So if you have a class name in the first one and the same class name in another one, and you're styling that class name in the first SVG, you should expect this will happen. Those styles will also be applied to the other one. The styles inside of an SVG are not scoped to that SVG if the SVG is embedded inline. The same problem if you embed the SVG using an object tag. By default, object provides us with a default way to provide fallback. If a browser supports SVG, it's going to display that SVG. If it doesn't support SVG, or if the SVG does not load for any reason, it's going to display whatever you have between the opening and closing object tags. Okay? So you can provide any kind of fallback there. If you want to provide a PNG fallback for that SVG, you should also use this technique here. Do not embed an image tag as a fallback because browsers are going to download both. So use this technique and use CSS background images. Whew. Thank you.